Okay, the last example, it involves absolute value, which I'm sure has caused you headaches in the past. And I'm going to try and explain this in such a way that at least some of your absolute value problems are going to go away. And before I get to this problem, I'm going to jump ahead to a new slide and talk about absolute value a little bit just to make sure it's clear about what I'm about to do here. The reason absolute value is such a problem is if I just make a function just the simplest absolute value available, is it's really made up of two pieces. And that's what makes it so complicated. Like two really separate pieces. Not like x squared where it's all one piece developing from one thing. It really looks like two separate lines. And that makes things complicated. Now, how do we deal with it when we have to try and do something algebraically? Well, I'm going to write a sentence that I think really helps to understand what I'm going to do algebraically. Let me just ask you this. If you take the absolute value of 10, what is the absolute value of 10? 10. Absolute value is really easy for positive numbers. You don't got to do anything. 10 is 10. How about negative 10? What happens to negative 10 when you take its absolute value? You get positive 10. So, I'm about to write this on the board, but what I want to say about absolute value is, the only thing you got to remember is, when the value is going to come out to be negative, you switch its sign. That's absolute value in a nutshell, okay? Because I'm about to do a little algebraic trick in a minute that's going to seem completely mysterious if you're not thinking about this sentence, absolute value. When the value inside is negative, switch the sign. This allows me to make a piecewise version of absolute value that's very, very helpful algebraically. So I'm going to do f at x equals only two kinds of numbers you got to worry about for absolute value. Positive numbers and 0. And what absolute value says is when you plug an x into absolute value, if the number's going to be positive, if you know it's going to be positive, you don't have to do anything. That's what we said just a second ago. F at 10 is 10. F at 5 is 5. You don't do anything. The answer is whatever x value you plug in. Whatever you plug into absolute value, you get the same thing back out. However, if the x happens to be negative, you've got to change its sign. And the way to algebraically change the sign is just to multiply by -1. It's just to make it negative. Let's make sure it works. If I plug -5 into here, absolute value says, oh, you got a negative number, you've got to go -5, which is +5. It seems like you're making it negative, but you're not. You're switching the sign. Because you already know it's going to be negative, so this negative gives you the positive. Okay? I'm going to use that in just a second. I didn't want it to be mysterious when I grabbed that trick out of my bag of tricks here. Back to the limit question. First move. And I was just doing the solutions for your next test to make sure I had your next test all figured out before I started teaching this chapter. And there's one in there where you just got to sub and get the answer. No fancy tricks, you just substitute in. So I suggest always trying that first. First sub in the -4 and see what you get. And here I get 0 over 0, which I said a lot about in the first part of this lesson. Let me just make sure I get all the right words here. 0 over 0 is called indeterminate. It means there might be an answer. There might not be an answer. There might be something to figure out here. It's not obvious what the heck is going on here. For our purposes, this means more work. Because it's a potential hole. I keep saying potential, and you're like, every one you've done is a hole. Yeah, I haven't done all the examples. There are situations where there's more to the situation than meets the eye, and we'll get to those eventually. But for now, potential hole. It means I can't get the value. I will never be able to get the value of the function. The value of the function doesn't exist. but I might find out where it's headed towards. And that's what limits are all about. I might be able to find where is it going towards with a little bit of work. Okay, here's my little bit of work. Here's the trick. I'm going to let g at x, and I only use g because just a second ago I did f, so I'll just change the name here. Let g at x equal this function that's inside here. But I'm going to rewrite this as a piecewise function because the absolute value is tough to work with algebraically. If you turn it into a piecewise, it becomes a lot easier to work with. Now, here's the important thing. This absolute value of x plus 4, I want to know when that part's going to become positive and when it's going to be negative. What x value is the breaking point between deciding whether what's in here will be positive and what in here will be negative? See, my other example was simple. When I asked, when does this come out to be positive or negative? Inside, you're like, well, when x is positive or negative. But it's just slightly changed here because, oops, wrong way. It's now x plus 4 in the brackets. So what x value is the breaking point here? Negative 4 this time, yeah? Because negative 4 is what makes this 0. So bigger than negative 4, it'll be positive. Less than negative 4, it'll be negative. So that's my breaking point between the two rules. X greater than or equal to negative 4 or x less than negative 4. This greater than or equal to, it actually doesn't matter where you put it. Because when it's 0, you don't need a rule. It comes out to be 0, right? Okay. So, let's just go over the rule for absolute value. If you know what's in there is going to be positive, you don't have to do anything. So in this particular case, if I know it's going to be positive, absolute value does nothing. I don't need it at all. You're like, you're just allowed to do that? Well, not exactly. I'm allowed to do it because I'm breaking this up and saying I know the x values are going to be greater than or equal to negative 4, which means absolute value does nothing. It just spits back the same number. Now, if it's less than negative 4, I got to do something to this. I'm going to get the wrong sign if I just write this. So I've got to change its sign. What's going to come out of there is going to be negative, and I need it to come back and be positive. What can I do to this thing to make it switch signs? It's so ridiculously simple and easy that it's really, really difficult. Because you look at it and go, so you just put a negative out there? I'm like, yes, I know physically I just put a negative out there, but what I did was change the sign of what came out of there. So I need to change that sign to make it absolute value. Okay, we're back to here. So what I get is this. If what's in the absolute value comes out to be negative, I've got to change its sign. And I'm just going to tidy that up a little bit and get the simplest, weirdest function you've probably seen in a long, long time. The x plus 4's cancel both times, so this function is 3 when x is greater than or equal to negative 4, and it's negative 3 when x is less than negative 4. Very, very strange, except completely simple. Here's the function. 1, 2, 3, 4. When we're greater than or equal to negative 4, and when we're less than equal to negative 4, we're at negative 3. Where is this dot? Neither place. Why is it neither place? You get neither spot on there. Because x can't equal negative 4. You can't plug negative 4 into this thing. So not only is it a hole, it's a jump hole. Weird. The end result being limit as x approaches negative 4 from the positive side of this function equals, do I have enough space in here? From the positive side, I get positive 3. From the negative side, I get negative 3. So the limit as x approaches negative 4 of this function, which I've called g at x. From one side it's 3, from the other side it's negative 3. What do we say about the altogether limit? Does not exist. And I got to tell you, mathematicians everywhere use this short form for does not exist all the time. You can write out does not exist. Maybe you should on the first few homework questions you do. But DNE is the universal does not exist symbol there. What questions do you have about absolute value? A whole page of thing, and all I really did, that was the only thing I really did that was tough, except it's really tough. It's really tough to see why I'm just allowed to put a negative in there. All I'm doing is changing the sign, saying, hey, absolute value changes the sign of negative things. If this is going to come out to be negative, I've got to change its sign. Oh, so what's the name of the strategy? Writing absolute value as piecewise. And like I said, I just did that while you were writing your test. I wrote your next test. I did the solutions for it. And all these strategies are right there. It's right off the hop. These are the don't use a calculator questions. You need to be able to factor. You need to be able to rationalize. You need to be able to change variable. And you need to be able to absolute value. And for once, the great news is you shouldn't have trouble deciding. What is it about this question that tells you it's going to be rationalizing? Square root. What is it about this one that tells you you're going to have to change what's going on here? Not square root, cube root. Even though I got to tell you, you can do, if you get addicted to this thing, once you get used to how to do this thing, it's really fun. And you could do the square root ones with that method as well, and that's fine. I'm not telling you you have to do these ones by rationalizing, but this is a more powerful method to handle it. How will you know that you have to do absolute value? Well, it'll be an absolute value. I mean, there won't be a big decision-making process either. It'll be like, bang, I know how to do this, or I don't know how to do it. That first page will go nicely. And then factoring, if it's not any of the above, but factoring also, no specialized things in there. No square roots, no cube roots, no absolute value, just polynomials. It's a factoring. You will learn about other types of limits before this chapter is over, but again, there's going to be giant hints in the question to know which method you're going to use, and those will just come along as we go. Back to here, though. Final questions about absolute value? Your brain's mush from the test? Is that, yeah, okay, that's good. So I won't teach again. You'll have 40 minutes to delve into this as far as you want to in the homework. But my brain's flashing about something. Is it, who printed out the chapter homework? Or can I bring it up on the screen? Something, what unit is this? This is unit 2. Homework list. Oh, there's questions on a handout. Were those questions in your printout? I knew something was wrong. There's some extra assigned work there. Oh, it's perfect. Got extra time tonight because there's all this homework to do? Perfect. You got these ones to work on and the questions on the handout. They go faster as you go. You know what I'm talking about? A quadratic formula. The first question you ever do in your life with a quadratic formula is like, and the second one's like, oh, it's the same. And this should be like that. It should accelerate as you get used to the different methods. Good?